welcome to all of you to this second dissemination webinar of our new initiative and not yet fully formalized initiative called Textile Circularity Multiplier. We had our first dissemination webinar here in late September, where we already presented a number of EU projects that are likely to become part of this initiative as we formally launch it in the next 2 months. The whole initiative is organized or facilitated, I would say, by the Textile ETP. So that's the organization that is hosting this call here. That's myself as the Secretary General. And then I have two of my colleagues here supporting, Camilla and Charlotte, who are helping to make sure that everything runs smoothly. And so just a quick throwback to and maybe an update for those who were not with us here in September. So the Textile Circularity Multiplier Initiative is an initiative that we're in the process of launching. It's not yet formally launched, but we hope it will be in January of next year. And the idea is to create a European expert forum, or we would rather call it then a community of practice, with the objective to learn and exchange about the developments, the latest developments, activities, and results in EU research and innovation projects that address textile sustainability and circularity. And I'll show you on my next slide that there are quite a few of those. And also in between or between those projects to foster collaboration on subjects of common interest, not necessarily between all the projects, but between selected projects or selected experts or partners in these projects to work on certain subjects they are in a way complementarily work on in their different project, and maybe put their resources together and create something new, some new outcome also in terms of input for EU policy making, for instance, and also to have this dissemination effect, so reaching out to a wider audience with those project results, and also to encourage obviously the quicker transfer of these results to industrial practice. So the initiative shall be carried by those projects. So, and we're in the process of confirming with those projects if they want to be formally involved in this initiative or not. So far we have, and then do a quick count, I think I see 9 logos on the left side of the slide. So there are these 9 projects that have so far formally confirmed their interest to join. The other 5 projects that you see on the right side are in the process of discussing that with their consortia. So we hope obviously that they will also confirm their participation. And then there's another 9 projects in the pipeline that are not funded by the Horizon 2020 or Horizon Europe program, but they're funded by the Circular Bio-Based Europe joint undertaking, which is a related program or sub-program actually of Horizon Europe. Well, we are in early stage discussions with these projects and their respective project officers to see if they want to come on board as well. So it's a process that is ongoing, and we really hope to build a fairly nice and large community of these projects. And one of the activities of this initiative should be in regular intervals to organize these kind of more public dissemination events, probably mostly in online format, where those projects or several of those projects of the initiative can actually share their activities, or as they advance further their results and their outcomes. So and that's exactly what we are planning to do today as well. So after my short intro here, we will have 5 projects that will be presented here today. And these projects are all linked, or at least have been contacted to join this initiative. Most of them have already confirmed. I think New Cotton, tExtended, and Waste to Biocomp have already firmly confirmed, and Scirt and MyFi, we're still waiting for these confirmations, but we're hopeful that they will also join. So this is, I think, everything I wanted to say as an introduction. I would then now hand over to my colleague, to Camilla, to guide you through the agenda and introduce our speakers, and then I will be back for the Q&A session. Camilla, over to you.
Thank you very much, Lutz, and also welcome everyone. So without further ado, I would like to introduce the first speaker. The first project that we are going to introduce is Scirt. It will be introduced by Evelien Dils from VITO, which is a Belgian research institute. And this is a little bit exceptional presentation because she couldn't be here today because the Scirt project itself has an in-person meeting with all the consortium today and tomorrow. So they are busy in meetings today in northern France, but she did record her presentation in advance. So let me share my screen and bring that video up for you, which should feel just like she would be here in person.
Hello, everybody. My name is Evelien Dils. I'm a researcher circular economy at VITO. VITO is the Flemish Institute for Technological Research in Flanders, Belgium. And I am the project coordinator of the Scirt project, funded under the Horizon 2020 program. And this project started in June of 2020, so last year. Scirt stands for System Circularity in Innovative Recycling of Textiles. I was asked to give a short presentation on the project to you. I will present the consortium, the objectives, and the approach that we have designed in order to reach those objectives towards the end of our project in 2024. So most of you will know that we consume on average a huge amount of textiles in Europe. This picture, it's a study from 2019 for the European Environment Agency, says that we consume on average 26 kilograms per person per year in the EU. Of course, in order to produce this amount of textiles, we need a lot of primary materials going into that system. We need a lot of water, about 100,000 liters of water, and we also require a lot of land to be used. On the other hand, besides the inputs, we also create a lot of outputs of this system. Think about CO2 emissions for the energy requirements and so on, as well as microplastic or microfiber emissions. But also a lot of waste is generated. There's production waste, but also on average, each European citizen discards about 11 kilograms of textile waste every year. From that amount of textile waste, most of it is still ending up as residual waste today in Europe. About 75%. And of course, that is lost. That is going into landfill, into incineration. And only about 25% is today being selectively, separately collected. That will then be sorted. What can still go into secondhand reuse? Part of it is still considered waste and is therefore, again, incinerated, for example. And only a small part, about 40%, is being recycled. The way it is being recycled or the applications in which it goes is often rather low value. This can be installation, for example, production of cleaning rags. But overall, the amount really going into new high quality fibers for textile production is really low, about 1%. Another element that we see is that the global demand for fibers and recycled fibers continues to rise. Also, the demand for recycled fibers rises as more and more brands set targets to increase the recycled content of the garments they produce. From the fibers put on the market today, more than half of it is fossil-based. 37% is renewable, and about 8% are recycled fibers, but the majority of those recycled fibers are actually rPET fibers, so coming from waste plastic bottles. So knowing the increased demand towards recycled fibers, the willingness of brands to do something with it, we also see that there is a mismatch between supply and demand. There are different barriers that we know today that create this gap between supply and demand for recycled fibers. It is the inferior quality, for example. So the specifications of the fibers, the recycled fibers that do not match with the expectations from the market, the limited availability quantities that are there today, as well as the higher costs that are still associated with recycled fibers. Moreover, there is still a significant lack of knowledge from brands and manufacturers, but also for consumers about quality and safety, for example, of recycled fibers, which again hinders the uptake. Besides these barriers, there are also underlying problems in the value chain. Some might be less obvious, but are key to be tackled in order to close the gap between supply and demand. These underlying problems are linked to collection and sorting, what ends up where and how as textile waste, but also to product design, for example, the use of material blends, set trims, additives that impact the recyclability of the product. But also the recycling technologies today are not really where they should be for closing this gap. It's still difficult for recycling technologies to deal with undefined inputs and to actually be scaled up today. Moreover, there is a lack of knowledge within a value chain as well as value chain collaboration. So it's really important if you want to close any value chain, any material loop, that there is this collaboration, cooperation between partners in a value chain and that there is transparency and communication. So it really requires integrated systems thinking if we want to close the textile value chain. And so the Scirt project has brought together front runners in the industry as well as research, and we aim to support and facilitate the transition to a circular fashion system through, on one hand, technological innovation, and on the other hand, the systemic innovation in the textile to textile value chain. The approach that we have set forward is really to close, of course, the value chain of textiles. We will focus on the fashion system. We chose to focus on a large volume problem that there is. We focus on the clothing that we all have in our closets and are actually being consumed at a pace which is enormous today. And we do this by involving partners from across the value chain that do production, that do that put on the market the products, do the spinning, do the recycling. But we also have additional partners in our consortium looking into these systemic elements. Since we have the ultimate aim to foster this demand from the market, so to have this market pull and increase also the likelihood of structural incorporation of recycled fibers into the design and the production of clothing, we want to look into a financially viable way of doing that. Why we think if we want to achieve that, we need a demand-driven approach. We need to start from the brands. We need to start from those organizations that put the clothing on the market and that also look into the use of recycled fibers. For that reason, our consortium includes 5 brands, each targeting different market segments in the fashion scene. Each of the brands have selected one garment, a typical garment that they have in their collections, that will become a demo in our project. By the end of the project, we have the aim to produce each of those garments with the highest recycled content possible while still respecting the characteristics and quality demands that the brands set for those garments. This picture shows the representativeness of the demos looking into circularity level, meaning the practices that they put into place already today, for example, offering repair service, already including recycled fibers, design for recyclability, and so on. But also the price level is shown. So in the segment that they are active in, this gives the picture where they position themselves. When we look at the different fabrics that we will look into, you also see that there is a very big variety. So also there we try to cover as much ground as possible to be as representative as possible. Also to be mentioned is that we also will look into ECOSYSTEX certification, because this is something Petit Bateau has today for their fabrics used. And of course, we want to see to what extent we can also get that certification for the new produced baby bodies. For each of the products that the brands have selected, they will define particular needs with regard to fabric quality, yarn thickness, color, and so on. And in order to reach these desired output requirements and specifications in a cost-effective way, we will have to tailor the different parameters of each step in the process. So we will have to look into sorting, dismantling, recycling, spinning, and it will have to be different, tailored, and we need to define that in our project. The ambition of Scirt is to map these parameters, feed them back into the supply chain of post-consumer recycled fibers, yarns, filament, and fabric, and make sure that we align with those specifications. So we want to make sure that we take into account these specifications going backwards into the production chain, making sure that we do everything we can leading up to the product and the recyclability to make the perfect recycling sequence. We take a stepwise approach, going first into lab scale and pilot scale testing, followed by industrial upscaling. As I said before, we will have the technological innovation. This is the material pooling side, so matching those product specifications with the best recycling sequence, identifying the needs and translating that back through the value chain, looking into what we need to improve on sorting and identification and dismantling, what that means for the recycling potential and limitations, and how we can also feed that back into circular design guidelines that are out there that we want to further develop or complement. And of course, we want to actually produce to check the feasibility and the quality of what we can attain. The other important element is the systemic conditions, so really developing enablers to facilitate this transition. There are different elements in that. Of course, the business model and the business case needs to be investigated, but also the importance and how we can implement value chain transparency. We will also look into the true cost of a garment, because this provides information that you can use as a consumer, as a partner in the value chain, as well as a policymaker, to really look into what is the true cost consisting of financial, environmental, and social cost. And we want to investigate whether this true cost method can be used in an eco-modulated EPR system, and whether this EPR system can then facilitate or create system conditions favoring a more circular value chain. And of course, we don't want to exclude the consumers. We want to talk to them. We want to know how they behave at the end of life of a textile garment. How do they discard of it? Where do they draw the line when they say this is waste now, I don't want to wear it anymore and it's not fit for reuse? But we also want to know their perception and acceptance towards fibers with higher recycled, towards fibers and garments with a higher recycled content. For this ambitious project, we have set forward a 3-year timeline. So we have now, we are now mid the second block, let's say. We have just finished the testing on a lab scale level to see how the quality and the specifications of the fibers align with what we have set forward. And we will continue, of course, by further designing this fiber-to-fiber system, producing the actual recycled yarns and filaments in higher volumes, also making sure that these are free from harmful substances. And at the end of the project, in 2024, we want to have in the stores the different demo garments with the highest possible recycled content, so optimized yarns, and with the lowest true cost possible. I would like to thank you for your attention. I hope me not being there with you was not an issue, and that you at least have picked up on the key elements of our project. You can follow us, of course, on Instagram, LinkedIn, and Twitter, but feel free to also reach out to me if you want to talk more about the project or want to follow us more closely. Thank you.
Camilla, you're muted.
Yes, I was muted indeed, sorry. So that was the Scirt project. So again, none of the project members are here today with us. So in case you have a question, indeed, as Evelien suggested as well, feel free to reach out to her, or eventually you can also put it in the chat and then we will put you in touch with her, or we can collect the questions, send it to her and circle back to you. In any case, wrapped up the Scirt project, so we are ready to move on to our second speaker. We are going to hear about the new cotton project, which will be introduced by Paula Sarsama from the Infinited Fiber Company from Finland. And she is here with us today, so I invite Paula to put her video on, share her screen, and take over the floor. Hi, Paula.
Hi, thank you, Camilla. And thanks for the invitation. We're always happy to tell about our project. Just going to share. So this works.
Yes, looks good.
Yes. Okay. Thank you. Yes, so I'm going to tell you about the new cotton project. My name is Paula Sarsama. I work at Infinited Fiber Company, which is a Finnish technology startup company, and I'm the coordinator of this project. So let's just go forward here. Well, I think the driver of our project is actually many of the things that were just told to us about the Scirt project, so many of the same issues. So there's only 1%, or actually under 1% of all textiles worldwide are recycled into new textiles. And we need to find solutions to reduce the pressure caused on earth and environment from textile waste. And of course, we have the EU's own plans to drive adoption of the circular economy within the textile sector. And this includes the plans that are related to textile waste collection starting in 2025. The new cotton project started around the Infinited Fiber Company, which is maybe not very typical that a small startup starts a project like this. Our company at that time was quite small. So we're a company that was started in 2016. And right now we have a bit over 60 people. But when this project started, I think we're maybe about 20 people. So we've been growing fast. And what we wanted to do is bring the whole ecosystem around our technology, or the ecosystem that's needed to actually prove that this kind of circular value chain is possible, and create like a circular model for commercial garment production. And what we see this is kind of like a blueprint of what we see the future as. So we see that if we can do it here, then this can be done in even larger scale. This here is our consortium. So we have 12 partners who have all their own role in this value chain. And because we have this chemical recycling technology, but as such, a technology alone can't solve the problems around circularity. So it's a tool to make this work, but it requires that we have all the needed stakeholders working together to solve this problem. I'm going to show you a short video clip of a few minutes about our project, because this tells the story of how our different consortium members, what role they play, and what's the driver behind this project. So I think the audio should be on. Just let me know if it's not, then I'll fix it.
So today, if you look at any industry across the world, we work in a linear function. We take things from the earth and then we make waste from that. In the fashion industry, the same is true. We're aiming to address the problem with linear production through the new cotton project. This project was initiated by Infinited Fiber Company and it was funded by the EU Horizon 2020 Research and Innovation Programme. It is a truly collaborative project that aims to test all parts of the process to bring about circularity in garment production. And in doing so, it really shows us whether we can move away from linear production.
The new cotton project really attacks a stream of textile waste that today goes straight into incineration. It will open up a whole stream of raw materials that can turn into new garments.
Revolve is working on materials estimates, so we work really closely with Franke House to understand the materials that they have access to and to document their feedstock development work.
We receive materials and we sort them with NIR technology to make sure that the content of cotton is high enough, and we take all the impurities out and then mill it down to a format so it can be used in the process.
Infinited Fiber received the salted textile waste from Frankenhuis, which is then being cleaned by XAMK.
XAMK is responsible for the chemical pre-treatment. So we get the mechanically pre-treated textile waste, we modify and treat them so that they are ready for the next step.
And from there we are receiving the cleaned material, which we are then turning into the premium quality textile fiber in Finna. And that's a beautiful replacement for virgin cotton. It can be used in a variety of different collections, and it looks and feels natural like cotton.
Kipas is a conglomerate company. Textile is the flagship company and producing spinning yarn and weaving fabrics. We get the fibers from Infinited Fiber, produce yarn and also denim fabric and dye it and send it to H&M for confectionery.
We are a spinning mill, so we have a large knowledge in fiber blends and making yarn of that, and also with cellulosic fibers. We transform the fibers that we get from Infinited Fiber in yarn.
Textina is a fabric producer, producing cellulose fabric from cotton. In this project, Innovafil sends us the yarn and we start the process. So from the yarn, we make a woven fabric. And then we have the finishing process. We decided with H&M that they want to have the print design on the surface.
H&M is a retail brand, so the face to the customer. Within this project, we really want to use the Infina fiber to test the whole circularity process and see if it meets the customer's expectations in the end.
Our role in the New Cotton project is mainly to design, develop and create garments. We've joined together to knowledge share, test and innovate new materials for our consumer, changing the industry from a linear to a circular economy. If we take waste out of the equation, we are all going to have to completely change the way that we think, create and consume.
It's imperative that the fashion industry becomes circular, making sure that we are not using the resources of our planet. One way is by using material that are circular, like Infina, where you take waste and make it into something new, and you're just closing the loop by doing that. So a constant circulation of the same material.
We are all going to have to think differently. We have all got to change the way that we operate almost all of what we do, and everything gets better. The experience of making the product gets better, the experience of using the product gets better, and we all become part of a system that will actually work.
In a climate crisis, recyclability and reusability are just as important as aesthetics and function. And so the New Cotton project helps to make that situation completely different. We stop wasting resources over time, and we stop putting such a tax on the planet.
We need to take action now and reduce our continued dependence on resources. This project, New Cotton Project, is a small blip in the ocean that demonstrates that that's possible, and we've done so very successfully. So my hope is that this project will serve as an inspiration for others in the industry to do the same. It's not an easy task, but it's one that we 100% can do if we work together in a truly collaborative fashion.
That was a presentation of our team. So the different partners we have in the the project. And here we have like a mapped out diagram of the stakeholders. And the university, Aalto University in Finland has been working on this stakeholder mapping, ecosystem, and business models. And it's been very interesting and actually quite an important part of our project to understand how this ecosystem works. Just a very short overview of the technology behind the project. So our the infinited fiber technology, it's called a cellulose carbamide technology. It's a chemical recycling technology where we can use different kinds of cellulose-based materials as raw materials. In this project, we focused completely on textile waste, post-consumer textile waste in this project. And this means that we aim at using materials with minimum 88% of cotton. So they can contain up to 12% of different of other materials, which are then cleaned out in our process. Infina is the registered fiber name that we use, which is the fiber that's born throughout this process. And it's a high quality fiber with a very cotton-like feel. And it can be further recycled again in the system, or if needed, it's also biodegradable. But the main idea is that it's high quality and in use, it can have a very long life. We are currently working on pilot scale, so we have 2 pilot factories in Finland, but we are currently scaling up and plan to open our first industrial scale factory in Finland in 2026. Well, what were the new cotton project objectives? So first of all, ensuring suitable feedstock. I think we all know that this is a tricky question, that there's world is full of textiles, but how do we find the right stream and how do we make these kinds of reasonable procurement systems? Of course, we have to develop and optimize our different technological processes, and also want to optimize the pilot scale production so that we can further go into industrial scale. Our brand partners, H&M and Adidas, were responsible for designing these activewear and denim apparels that I'll show shortly. And all the stakeholders in between before the fiber is actually created into these garments, they had a very important role in carrying this out. We also need to evaluate the recyclability, sustainability, and safety of the textiles made from the Infina fibers, and also demonstrate the consumer interest on these apparels. And as I just told you about the work that Aalto University is doing, that we need to boost circular innovation and stakeholder collaboration in the textile sector and study circular business models. Here's a very, very sort of broad overview of what we've been doing and what we're about to do. So the project started in October 2020, and what we've done so far has been doing all kinds of basis work in the technology, fiber processing and production, testing the yarns before actually fixing what kinds of yarns will be used in the commercial launch. And this year has been very important for us because we produced the fibers, the yarns, the fabrics, and finally the garments for the commercial launch. And this commercial launch of the new cotton garments was done in October. I'll show you something about that shortly. Following year, we still have lots of development work going on, LCA work. We're also launching some other garments with a bit of a different type of material. So these are the the products that were launched onto the market from our project, which we're quite proud of. This brown denim collection it's a unisex collection by H&M, and then the Stella McCartney hoodie and track pants on the right are from Adidas. And these entered the European online stores in October with a capsule collection. But what have we learned so far? We've learned a lot of things. We still have to a lot of things we haven't decided to disseminate yet, so I can't tell you everything yet. We're still planning on how to launch that. But one thing that we have really noticed, that the sorting phase is the key. So something has to be, or there has to be development in the collection and sorting actions. And there's many challenges, but there's also opportunities, and this requires really cooperating between the stakeholders. If the collector or the sorter doesn't understand the needs of the recycler, there's due to be problems. So that really requires having like dialogues between the different stakeholders. Also, fiber identification technologies have limitations, and there's a lack of a unified way to sort. This is something we're still working on very heavily, and we hope to get some progress there. Then a bigger question is, of course, that the mandatory reporting requirements for fiber composition in textile products would help to assess the recyclability of materials on the market in a more reliable and efficient way. However, there aren't these requirements don't exist yet, so there's still a lot of work to be done as a large from the whole industry. Designing for circularity has also been one of the key topics, and understanding what kind of requirements there is for material selections. For example, what kinds of mixed fibers can be used, and avoiding using them. Also, this communication of the different stakeholders in the value chain. So it really has to be a see-through value chain, that we share experience and knowledge throughout the stakeholders, because there are very special expertise in each and every step of the value chain, and there needs to be a mutual understanding. Something that may work in one step may not work in the other, and there has to be compromises made. But we really believe that this has been an excellent way to test and learn about the process, and offers us, or it's been crucial for our company to understand this, especially now that we're going towards industrial scale production. From my side, this was all a very quick overview of the project, and I'm glad to if anybody's interested, to give you more information about this. Thank you.
Thank you so much, Paula. And indeed, I see there is already one question for you in the chat, but this is something that we will pick up at the end during the Q&A. So please stay with us. And also maybe if you have a direct link to the video, you can just drop it in the chat, so that those who couldn't see it perfectly can later watch it. And with that, I would like to move on to the next presentation. We are going to hear about the MyFi project now. It will be presented by Silvia Gava from Mogu from Italy. And I see you already on screen. Hi, Silvia. So please take over the screen. Feel free to share your presentation, and the floor is yours.
Perfect. Thank you. And thank you for hosting us today and giving us the opportunity to share about our project, the MyFi project. So we are changing a little bit the topic here today because we are talking now about new environmentally responsible materials, so an alternative to recycled materials, something different, and moreover, not really a textile, but a non-woven material. So MyFi stands for mycelium fibers, and I'm going to tell you a little bit about how this project was conceived and born, and which are the main challenges that it's going to face. And then I will tell you why mycelium fibers and what is the project about. So first of all, and it is in line with what Scirt and New Cotton have told before, we are living in a world that's full of challenges today. And here we have targeted two main challenges. The first one comes from the consumers, which are demanding for new, functional and sustainable products. And on the other hand, we have the industry, which is the other challenge for us, the textile industry, which is feeling a high pressure about its environmental impact. And I'm talking about the wastes that it generates, the microplastics, and then the two main characters, as always, so the CO2 emissions and the water consumptions. So these challenges are also in line, and what we are trying to do is in line with the Sustainable Development Goals. And here I have reported the three main ones that we are targeting with our MyFi project. So supporting domestic technology development, since the project allows to produce a new material also locally. And then we are helping in promoting mechanisms for raising capacity for an effective climate change related actions. And then in the end, a sustainable production and recycle and reuse in circular economy. So this is the main scenario. And now our question. So how is the MyFi project targeting these issues, these challenges? Our mission is to develop an innovative material, a new material, which is environmentally responsible, functional, and a high value, and which is allowing us and the users to shift from an exploitative approach to a generative one. But exactly what is this new material? What is it made of? It is made of mycelium. I don't know if you are already familiar with mycelium, but in a nutshell, it is the vegetative part of fungi. Fungi are not only the mushrooms that we can see in the surface, but they are really made of this hidden vegetative body that grows underneath, and it is made of hyphae that connect together, and if they are grown in the proper biological, environmental conditions, they are able to create a new non-woven material that we are growing, because we are really growing this material, and we are proposing it as an innovative product for the fashion industry, but not only. Why are we shifting our approach? We are not exploiting the exhaustible resources, but we are really cooperating with nature in order to, let's say, leverage on renewable resources that can be grown on residual or low-value substrates. So we are collaborating with nature to grow a new product. And in this way, that's how we are targeting those issues that I have shown you before. So we are empowering the textile industry to face those emerging challenges by offering a new material. We are also meeting the consumer's demand for new and sustainable products. We are relieving the environmental pressure related to the textile industry, and of course, to make all this feasible and on a large scale, we are engaging the stakeholders and provide guidelines for policymakers. And that's our objective. This is a very quick overview about the project. So it's called MyFi from mycelium fibers. We started in November 2020. It's a 4-year project, and we will end in 2024. So we are halfway towards in our project. And the project has been funded by the European Union with a grant of around 5 million euros. How it is organized? How is it structured? So how are we going to do that, to make this? The first step is about biofabrication. So I hope I gave you an idea, but then I will show you a short video that may make things clearer. The first step is to take low-value residues. We inoculate the fungal strain on these residues, And through different fermentation techniques, the mycelium, the fungus, grows on it, and it grows as a new layer on the surface. Then we gather it, we dry it, and we have like a panel made of 100% mycelium. Then the product is very, I'm afraid that we are online, but I hope that one day you will have the chance to touch it. It's very velvety and very pleasant to the touch. But of course, we have to proceed with post-treatment in order to improve not only its aesthetical properties, but most of all, its functional properties. And I'm talking about mainly mechanical properties. That's why we are working with tanneries and with university and research centers who are experimenting new ways of treating the material in order to transform it in a finished one, so from raw to finished. It's a continuous process of feedback, since we can act on how the material grows. We can act on biofabrication in order to get a different material in terms of density, thickness, dimensions, and on the other way, they receive these characteristics as inputs for the transformation process. What we are starting from are processes that are very similar to leather, treatments for leather, but we are adapting it to a new material which has a completely different structure, since we are not talking about collagen, but we are talking about chitin. So it's also a way to experiment new processes. Then once we have a finished materials, we are scaling up both the biofabrication and the post-treatment process. Scalability is paramount because it makes this process appealing for the industry. And of course, also cost-effective and available for the markets in the right quantities, and of course, accessible in terms of price. The process has been proven successful for the scale up in terms of biofabrication for the fermentation processes that we are using. And on the other end, we saw that it is also very adaptable to, for example, the process that tanneries are implementing and to their equipment. So we are in the middle of the scale up, but it is providing very positive results. Then what are we using it for? One is it's finished and scalable, mainly for the fashion and automotive sector. So in our consortium, we have members from the fashion sector and members from the automotive sector. Of course, they require different characteristics in terms of aesthetics and performances, and that's why we are not delivering just one kind of material, but different kinds of materials with different finishings or a different biofabrication process at the very basis. And then in the end, this whole process is followed by an LCA and LCC analysis in order to assess the environmental performances of these materials. So far, we don't have the LCA and LCC finished, but it is ongoing. But what I can say to give you an idea is that the material, the raw material, is 100% biodegradable, and then the assessment is ongoing for the finished materials, since we are applying, of course, some additives. In this sense, we are studying parallel, we are, let's say, go through parallel paths. On one way, we are using sustainable materials, natural products, and on the other way, we are applying more traditional techniques in order to study and understand the trade-off between the sustainability and the performances. This is really something we are working on, so exploring all the paths. And then here, a short video. It's just to show you and give you an idea how the fungus work. This is a substrate, a natural substrate, and that's part of our circularity, since we use a residual substrate from the agro industry or low-value substrates that have no other valuable use. When we inoculate the strain, this white hyphae, the very little roots that you can see, is the mushroom, the mycelium itself. And it is colonizing it all, acting as a natural binder, and then growing on the surface. And through a patented fermentation method, we can then gather it from the substrate, the feedstock on which it grows. So I hope it gave an idea. And here on the right side, you can see a row panel of mycelium. So why are we so enthusiastic about this material? Because it really has unprecedented opportunities. And here I've drawn up a little list about the main opportunities. First of all, aesthetical opportunities. A new material should also have its peculiar characteristics and its way to be distinguished among the others. And I may say that the mycelium fibers really has these characteristics. Then the process is sustainable and circular. Circular because we start from low-value residues or recycled residues, and sustainable because it really has little consumptions in terms of CO2 emissions and in terms of water and land use. Our main benchmark is leather, even if this product is not leather, but the applications are very similar. So it can be used for ready-to-wear, for example, leather goods. So we use it as a benchmark, even it is not leather at all. But compared to that, it has a very well-performing impacts in terms of water, land use, and again, CO2 emissions. Then, as I was saying before, the properties can be engineered. And that's an amazing opportunity according to us, because we don't receive the material as it is. It's not something that we are passive about. We can collaborate with the material during its growth, and by regulating the parameters during its growth, we can reach different thicknesses, a different density, and other properties about it. So it's really something that we are continuously investigating because it has still unexplored properties. Then the whole process just takes a few weeks. It's a three-week process. And if you compare it with the other materials, of course, you can see that it is pretty competitive. Then it can be grown in any size and shape. Indeed, as you may have understood from the video, the mycelium takes the shape of the mold it is put in. So theoretically, it can be grown also on a football field, let's say. Of course, you should regulate very well all the parameters, and it's not so feasible, but it is an advantage for modeling and design also new garments. For example, in the future, if you need to build a bag, you can grow the pieces of the bag in the exact shape you need them, so avoiding all the cuts. Of course, again, here we have a trade-off between a high cost for customization, but of course, less scraps and less wastage. Near zero losses goes as a consequence, and also the process itself. We are studying how to reuse the feedstock for the growth for a second fermentation. So also here we are trying to keep it circular through its whole life cycle. It's scalable, as I said before, and since it's scalable, it should reach, after the industrialization process, a cost which is competitive. Moreover, you should also consider that no big raw materials or inputs are required for the growth itself. And then for those who are interested, of course, it's vegan friendly. No slaughters at all are implied in this material. But not all that glitters is gold. So what we want also to discuss are the next challenges that we should face. First of all, it's not always easy to enter a new market with a new material. There is a lot of skepticism about the performances that this material may have, or also at least to know that it exists and how it can be used. So what we should do is really to raise awareness about new alternative materials, and not only us, but about all the alternative materials. For example, you may see that there are other companies producing mycelium materials, and if they succeed, it's also a positive thing for us because the whole market, since it is a new market, it thrives really as a consortium. So we are not happy if one of our competitors, let's say, fails, because this is a very new thing, and it is important that in terms of awareness and the presentation of the material, we are consistent in the whole industry. Then the material is also being compared to what is already existing on the market in terms of aesthetics, scalability, costs, performance, and functionalities. So yeah, of course, it is an innovative idea, but we have to make also this. It's not enough. What I'm saying, it's not enough because we have to make it work in terms of aesthetics, costs, and performances, of course. And that's something we are really working on. Indeed, in our stakeholder advisory board, we have many partners coming from the industry, upholstery, fashion again, automotive, and it's important for us to receive feedbacks from them. And then very last thing is that what we are aiming to do is to make this thing real. It's not only marketing, it's not only a beautiful idea, but we should be consistent with what we are saying, and our final goal is also to make something that is indeed deliverable. That's it, and here you can find some contacts about our project. So I invite you to follow us on LinkedIn and on Twitter. So thank you very much, and I hope it was useful.
Thank you very much, Silvia. Useful indeed, and also very interesting. Again, you have no, you have not received yet questions, but if anyone has questions to Silvia, please feel free to drop them in the chat, and then we will pick them up at the end. And with that, we can move on to our next speaker. We are going to hear about the tExtended project now, presented by Pirjo Heikkilä from VTT from Finland. Hello, Pirjo. Please feel free to take over the screen.
Hello, thank you. So I'm Pirjo Heikkilä from VTT Technical Research Center of Finland, and I'm going to present to you something which is very different states compared to other projects presented here today. So let me try to share my screen. Okay. So tExtended project is we don't have any slide set yet. So actually this project officially started last Thursday. So we signed grant agreement 2 weeks ago, and official start was 1st of December last week. And I'm mainly kind of forced to rely on the illustrations from the project proposal. Yes, tExtended is project is called Knowledge-Based Blueprint for Extended Textile Circularity. And what is kind of main idea in this is that we want to build this kind of knowledge-based blueprint, kind of master plan for sustainable circular textile ecosystem. And as a basis of this blueprint is conceptual framework. So it's determining what is the optimal way to utilize different kind of textile flows. And it's aimed for retention of value, high value of materials, but doing it safe and sustainable way. And we are going to also demonstrate using of this blueprint. So this kind of real scale demonstrator, and we are expect to also verify its replicability and potential to reduce textile waste by 80%. So these are targets from the call. And this demonstrator will be enabled by development of technologies and digital solutions needed in this kind of textile systems. So this was twin transition call. We are doing both green and digital transition solutions in this project. This is an illustration kind of showing what is the blueprint. So we can take a look on the whole textile system here. Conceptual framework, which is the optimizing solution, how each textile fraction should be recycled. It's kind of based on identified quality. And for that, we also are building classification of textile waste materials. It also kind of takes into account what was the previous life of the material and also what are the end use requirements of the next using round. It is, like I mentioned, it is safe and sustainable in kind of inherently, so we are using also environmental evaluation and social impacts are evaluated for this, and also economical. So this is kind of a large optimization system. But we are having textiles coming from different sources, side streams from industry, but also used textiles on recovered different ways. Identification things are important, like mentioned in all, some of the other presentations as well. And also we want to develop new systems for identification and sorting, but also what can be done for textile waste before it actually kind of, we have to decide where it's going. So pre-processing and waste valorization, what's happening before the conceptual framework and evaluation of material. And then our options include reuse as products, reuse of textile materials for remanufacturing, for example, of course, mechanical recycling, and then recycling of fiber raw materials, so thermomechanical and chemical means here for the recycling. We are looking for taking materials back to textile sector, to textile material manufacturing, product manufacturing, and on the different textile using sectors, but also for a kind of other sectors as well. So this is kind of blueprint and this conceptual framework. And once we have done this, we are doing this real scale demonstrator, and this illustration also shows our consortium. So we are testing this system kind of in full scale within our consortium. We are partners from Finland. In addition to VTT, we have Rester and Municipal Waste Management Organization of Southwestern Finland. From Sweden, there is Research Institute of Sweden and ECOSYSTEX. We can take a look also at kind of environmental impact on logistic and transfer of materials. Also, in part of the demonstration, especially we have partners from Belgium, so Centexpel as research institute, Purfi for mechanical recycling, Utexpel for work clothing, and then Green Loop Winkel for reuse of products. We have also a large group of participants from Portugal, CITEM as a research institute, and then also INESCDEC for research partner for these digital solutions. MTEX for new technologies, Textile for mainly for the technical textile side, and GF Almeida for home textiles and textile products. From Spain, we have iPlus, plastic recycling partner, so Plastic Research Institute, and then Soprema from France for upscaling of chemical recycling here. So these are not yet all. So from Switzerland, we have Talivale presenting clothing side of the end users, and within this group we are carrying out the real scale demonstrator. It will be then kind of replication potential are studied in smaller areas, for example in Scandinavia by VTT, but for Baltic countries. So we have Green Liberty from Latvia, doing the study there and supporting in other activities, and Nara Slovensko from Slovakia to do the study in eastern side. And also on the kind of Central Europe and southern part with this. And car communication is our communications partner. I think I have mentioned all our partners in there. Here is also illustration on the project plan. So we are starting by having this work package which provides overview of the value chains and shared data and symbiotic interactions in this textile circular economy, kind of building the basis for all research work which will be then carried out. Work packages 2 and 3 will be focusing on the technology and digital solution development. So this is innovation action taking technology readiness level from 5 to 7 here. So work package 2 is what is happening before. We use the conceptual framework, and then work package 3 is recycling technologies. So focusing on the activities and developments done on this side on the picture. And then here is more theoretical work. Here work package 4 is building up this textile classification system and also collects the lifetime data and develops this conceptual framework for determining of this optimized recycling route in safe and sustainable way. And then in demonstrator work package, we do a lot of different type of activities. We make this blueprint, kind of implementation plan of the conceptual framework. So planning of the demonstrator, we carry it out within the joint forces of our consortium. And then there will be replication potential study in different regions, like I showed here. We have more localized activities in different regions, and so how well we can replicate our use of this blueprint. And then there is, of course, evaluation of sustainability, circularity, and also kind of technological and non-technical barriers related to overall system. Since this is just started, I think during the project there will be quite much more technologies available, and replication will be easier than it would be at the moment. And we will take a look on what is happening also outside of our consortium. And this Textile Circularity Multiplier initiative is a good way to also have a contact with the other projects. But here, shortly, kind of summary of the basic information. So grant agreement, like I mentioned, signed a couple of weeks ago. It was call was included in processes for planet partnerships, so circular flows for solid waste in urban environments, twin transition called, VTT is coordinator, and all together we have 20 partners. Total budget, including the partner from Switzerland, is slightly over 50 million euros, and EU contribution for that is 12 million euros. Duration 4 years, and is also linked to other activities in EU. So this was marked as hubs for circularity call topic. Industrial urban symbiosis is important in here, and also it needs to be linked to European community of practice. And I think this textile circularity multiplier is also kind of working for that demand from the call. Our draft for logo, let's see, do we have that confirmed? But our kickoff meeting will be in January, so we are just about to start. And here are my information if somebody wants to ask more details. Thank you.
Thank you very much, Pirjo, for introducing this very new project, and good luck for the start.
Thank you.
And now we arrive to our last presentation before the Q&A today. We are going to hear about the Waste to Biocomp project, which will be presented by Helena Vilaça from Scirt, Portugal. Hello, Helena. I see you're already getting ready. Please feel free to share your screen.
Hello. Let me try. I think it's okay. Do you see my screen now?
Yes, perfectly.
Perfect. Okay. Well, first of all, I would like to thank you for the invitation to be here today. I'm Helena Vilaça from CITEV, the Textile Technological Center in Portugal. I'm a researcher in Department of Chemistry and Biotechnology, and I'm also the project manager of this project that I'm going to present here. The project is Waste to Biocomp. The main title is to convert organic waste into sustainable bio-based components. So here we are going to focus not only on textiles, that's what our main aim here in the projects presented here today. We have other value chains, but one of them is also textiles. That's the one that we are going to focus more here today, at least. So just a quick show of the topics I'm going to talk about. I'm going to first show you the motivation, what led us to write this proposal, and then give you some data of the proposal and the project, show you the consortium of Waste Biocomp, then talk to you about the value chains that are approached in the project, the main objectives, the concept, the structure, the overall structure of the project, and then the expected results. So in terms of motivation, the motivation is basically what was already mentioned here today in the previous projects presented. But here we focus on three value chains. We focus on textile, packaging, and footwear sectors. In terms of, but all of these value chains, they have the same problems. We have tons of waste that are being produced every year. Most of these waste just end up in landfills, or they go to incineration. In terms of, for example, in the packaging, we have the problem of the plastics and the formation of microplastics that end up in the. Sorry, what is happening here? Let me just. I had a problem with my slides. They just started to jump up front and backwards. The microplastics that end up in the ocean and so on. And in this project, we aimed, or at least we identified that there are some bio-based polymers components that have a huge potential to be used in all of these three value chains. We focus on PHAs, polyhydroxyalkane weights, and they have been showing some potential to replace fossil-based plastics. So we are going to focus on textiles, but here more on replacing synthetic fibers like polyester and polypropylene. You are focused on the packaging and also on the footwear. Despite the potential that PHAs have been showing, they still have quite some limitations. Their production is quite limited, and their properties also, because to have the PHAs with materials with the different properties that we require here, or to make the fibers, or to make the plastic films, or to make foams for the shoes, we need PHAs with a lot of different properties, very, very different. So their production and their properties are still quite limited. So the aim of this project is to overcome that main problem. So if we go now to some data about the proposal and the project, these projects the proposal was submitted on the first call of the Horizon Europe program under Cluster 4, the digital industry and space. It was a twin transition, okay. And under this cluster, there were 104 projects approved, of which 26 were with Portuguese participation. So we have, in terms of Portuguese participation, we have around 20% approval rates. This is just the number of the grant agreement that was signed in May this year. The timeline for this project is of 36 months. It started in June, and it will end up in May of 2025. It is a research and innovation action. And the maturity level, we start in around 3 to 4, and we are going to end up in TRL 6. That means the technology demonstrated in a relevant scale, in a relevant environment. So the total funding was close to 6 million euros. In terms of the consortium of this project, the consortium comes with 13 European partners. They are spread in Europe, more or less spread in Europe. We have 3 partners from Germany, NORA, Kaiserslautern, the University of Kaiserslautern, and IVW. We have 2 partners from France, Pili and Nixa. 1 partner from Spain, the Universidad de Coruña. We have 1 partner from Italy, Proper Group, 1 partner from Switzerland, it's Green, and we have 5 partners from Portugal. CITEV, us, of course, Magellan, we have Inestec, Riopel, and MTEX. So from these partners, 4 are SMEs. We have Pili that develops pigments and dyes from bio-based sources. Nixa is for the inkjet printing. Proper Group is production of plastics. And Green develops recycling technology for plastics, and here also for the textiles. We have 3 large industries, NORA for the footwear value chain, Riopel for the textile, and MTEX is from the digital inkjet printing. They develop equipment for the digital inkjet. 1 association, Magellan, that is helping in the coordination and also responsible for dissemination and the communication of the projects. And we have also 5 research entities that are going to make the R&D in all of these 3 value chains and develop the BHA's materials from different raw materials, and then also develop in lab scale the components, the different components for these value chains, and then help the companies to scale up to a pilot scale. So in terms of the value chains, they were already mentioned. We have the textiles, footwear, and packaging. In terms of textile, we are going to focus more in non-woven and non-woven coatings over woven fabrics. In the footwear, we are going to develop soles and insoles for different types of shoes, orthopedic and sports. And in the packaging, we are going to develop both flexible and rigid packaging. And we can say that we have another kind of value chain that is or another kind of manufacturing process, that's the inkjet printing. That covers all of this, is going to be applied in all of these value chains. But the innovation here is the inkjet printing with bio-based inks. That's something that we still do not have in the market. In terms, the main objective of the project is it's to demonstrate relevant scale production of bio-based products and materials as alternatives to replace the traditional materials that currently have a high environmental footprint, as was already mentioned several times here, by using innovative manufacturing technologies that cover all of the life cycle of these materials and allow the use of these materials in a closed loop. More particularly, we aim to develop bio-based components. We have different precursors like the PHAs, capsules, particles, dyes, pigments, etc. We have the materials, going to be textiles, the plastic films, foams, and then the final demonstrators for these three value chains. We also aim to develop smart manufacturing processes, as for example, the inkjet printing, the electrospraying, compounding, thermoforming, microwave-assisted chemical recycling, and also aim to develop end-of-life. That's really important, of course, for this circularity. We aim to develop different end-of-life alternatives. We are going to try to different remanufacturing approaches of the printed textiles and garments, and also from the shoe soles and insoles. Try to remove the color and reprint it, and then also try different chemical. Sorry, I don't know what's happening, but someone is taking control of my presentation and I just lose my slides and start seeing other things. I'm really sorry for this. We are also develop different chemical recycling approaches by the polymerization and repolymerization of the PHAs, and then try to use the obtained recyclates as feedstock to obtain, again, new PHA materials or new foams. Another objective of this project is to develop training materials, because if you are going to develop new bio-based materials and adapt the technologies or the manufacturing technologies and processes for these materials, we need to train a new skilled workforce for these processes. And of course, we are going to make all of the toxicity and sustainability assessments, show that these materials will not have any kind of toxicity problem. And in case some of the materials developed are not recyclable, we are going to show that they are compostable and are biodegradable. Of course, we are going to, in terms of sustainability, we are going to do LCA, LCC, and SLCA studies, and of course, assured compliance with the existing and any new standards and regulations. Now, going to the concept, the overall concept of this project. Of course, we are talking about 3 different value chains, so it has to be a little bit complicated concept. So if you start with the raw materials, we are going to use different raw materials from bio-based source, all of them, and then develop the precursors, like the bio-based PHAs, proteins, microparticles, functional capsules, the dyes, and from the dyes and pigments, bio-inks that can also have the capsules. And then from these precursors develop the materials. We have bio-based fibers, foams, the films, the different composites, and also printed substrates. The printed substrates, of course, include all of the materials previously referred. And from these materials, we are going to develop demonstrators for each of the value chains. For the textiles, we are going to develop face masks, fashion garments. For the shoes, we are going to develop soles and insoles, and also printed leather. And for the packaging, the plastic films and rigid packagings, and also printed paper that is used in different packagings. And of course, we are going to exploit the end of life by exploiting different approaches. I already mentioned remanufacturing, the recycling, biodegradability, and or compostability. And then, of course, all of these will be, let's say, included in the toxicity and sustainability assessments, in the training materials that are going to be developed, and they have to follow all the standardization and regulations that we have, and even possibly contribute to new standards, that we still have some lack of standards specifically for the bio-based materials and their characterization. This could not be achieved without the use of different technologies. We have organic chemistry and fermentation, encapsulation, electrospray, the inkjet printing, color removal, recycling, and so on. The structure of the project. The project is divided in 8 work packages, main 8 work packages, and then a further 9th work package related with ethics. Work package 1 is the development of our precursors. Of course, we have to start with that. We are going to develop the application tailored biopolymers, precursors, and additives. And then the materials developed in work package 1 will feed work package 2 and 3. In work package 2, these 2 work packages, they are associated with the development of the technologies or adaptation of the technologies for these new materials. And in work package 2, we are going to develop smart inkjet printing for this bio-based, for the position of the bio-based inks. And in work package 3, we are going to develop smart manufacturing processes for the foams, the films, composites, and textiles. Of course, then we have these materials from these 2 work packages. They are going to feed work package 4, where we are going to develop the demonstrators and validate them. And any problem during this demonstrators development will have give some feedback to work package 2 and 3. We make the necessary changes and then go again to work package 4. Of course, this is all interrelated. And then in work package, from work package 4, we are going to work package 5 and 6. These are related with the safety and sustainability assessments. In work package 5, we have the remanufacturing and recycling approaches, while in work package 6, we have toxicity and sustainability assessments. Of course, and the recyclates obtained in work package 5, they can also feed back to work package 2, 3, or 1. And for work package 6, we are not only going to test the toxicity of the final materials, that makes no sense. We have to start from the first materials that are going to develop in work package 1, because if any of the PHAs or any of the capsules, we do not foresee that, but if any of them shows any toxicity, we can just exclude them and do not use to further development of the materials. All of these projects, all of the project and all of these work packages are being followed up by work package 7 and 8. 7 related with dissemination, communication, training, exploitation, innovation management, and work package 8 for the project management. These 2, they go all of the timeline, the 36 months of the project. Now, in terms of the expected results, we already have some preliminary results, but I'm not going. We are still quite soon in the project, so I'm not going to talk about them. But in terms of the expected ones, we expect mainly to have a significant impact on the reduction of the use of fossil-based materials, not only in these value chains, but also in other several sectors and applications that we can use the materials developed here and even the processes that are being used here. In particular, we aim to obtain tailored and safe bio-based polymers and additives, the polyhydroxyalkanoates, the polyhydroxyalkanoate micro nanoparticles, functional kosher nanocapsules, bio-based different bio-based inks formulations. We are going to develop smart inkjet printing systems that will be able to print bio-based functional and color inks, and also they are not only going to be able to print on 2D substrates, but also 3D substrates, allowing the user customization that is now a trend. Of course, for the other materials, we aim to develop, or we expect to obtain at the end of the project, different smart manufacturing processes adequate for these materials, with a low capex investment and high cost effectiveness. That's very, very important, because if the process is too costly, it's not going to have it's not going to be a good result, and its implementation in the market will be very much difficult. So we'll go into to obtain demonstrators validated in relevant environments with no toxicity and comparable. We aim to achieve this, that our bio-based demonstrators are at least comparable in terms of properties with fossil-based benchmarks, if not better, but at least comparable. So we also expect to create a skilled workforce in bio-based manufacturing sectors, and to develop alternative solutions for the end of life of the demonstrators. And that's all. Thank you all for your attention, and sorry for these problems with slides jumping.
Thank you very much, Helena, and we are sorry too. It happens sometimes that someone accidentally takes over. I saw someone also apologize in the chat, so I think we made it work at the end. Thank you, and thanks to all of our speakers today. So now we arrive to the Q&A session, and for that I would like to hand the floor over to Lutz, who will coordinate this part.
Yes, thank you very much, Camilla, and also thank you from my side to our speakers, the ones present in person, and also the one who provided the video presentation, who unfortunately we cannot question here. So as Camilla said before, if you have any questions to Evelien for the Scirt project, then well, you can pass it to us, or you directly contact Evelien through the contact details that we have. Maybe even, Camilla, if we can paste Evelien's email address in the chat here, so that makes it easier for people to follow up with her if they have questions. So let's then open our Q&A session. I've seen there were a few questions already in the chat, and some of these questions were kind of immediately answered, so maybe we don't need to repeat all of this, and some of the questions were quite extensively answered. But let's maybe go presentation by presentation. If I can ask Paula perhaps to come back in video and sound. Well, I had a question to her, which, if I haven't missed it, maybe you haven't answered yet. You mentioned one of the issues is the labeling. for the recyclers or the sorters and the recyclers. And I was wondering what the exact problem is in the with the labeling. Is it because labeling as such already, or composition information has already mandatorily be included in textile products on the EU market, but there are certain sort of technicalities that certain items, certain materials below, I think, a 3 or 5%, I'm not 100% sure what the limit is, doesn't need to show up on the label. And then the other problem that I can think about definitely is that often labels are either missing when products reach the waste sorting collection stage, or even if the labels are still there, they're not readable, at least not human readable. So, but maybe there are other issues around that, and I wanted to check with you what the exact reference you made to the fiber composition was.
Yes, so I didn't answer that in the chat because these are kind of it's not an official answer, but the gut feeling that we have and what we've noticed in our research is that the information that's on the label isn't necessarily the truth. Okay. So there's been very big deviations of the truth of what a garment includes fiber-wise when compared to the label. So that's a big problem, that we can't trust what's on labels. Then of course there are differences of where these clothes are coming from and what kinds of manufacturers and things, but that's the main problem, is that we can't trust what's on the label. Another issue is, of course, when you think of the sorting process, they don't have time to look for the label, and where can they find the label and try to read it. So this is also something when we're thinking of making the sorting business economically feasible, it has to be fast. So this is, we have to think of textile waste. It's a raw material that will cost something. It's not free, even though it's waste. But in order for this to be any kind of business or a business model for these sorters and collectors, they have to develop this automated systems and make the separation quick. And with these labels, they don't really help in that sense. So for us, it would be best if there was something integrated into like some kind of a sensor in the fabric that would tell us right away what it is.
Yeah, and obviously these labels were, of course, not designed to inform the recyclers. They were designed as a tool to inform consumers, which is a slightly different. I mean, obviously the truth should be on a label, but the actual requirements are a little bit different. So I think as a processor of a material, you have to be much more trusting of what the information about the composition is than let's say as a consumer, where obviously you may have a preference for one material to the other, but as long as the product serves its purpose, is probably okay. But if you want to process something and then the whole process doesn't work, or you have disruptions in your process, then this is a much bigger problem. Yeah. Okay. Well, that's very clear. So the other, I'm just going quickly through the chat. If there were major points there, I think there were questions on what kind of materials other than cotton you can work with, and I believe you answered that. That you can also process other cellulosic fibers with some adjustment. So that mainly relates to probably man-made cellulosic fibers, such as viscose and lyocell, these kind of fibers.
Yeah, we can use, for example, like cardboard or straw or other pulp, but it's always, of course, we have to adjust the process to the raw material.
Okay, maybe then before we move on to the next speaker, are there any other questions to Paula here that have not been put in the chat? Anybody who would like to ask a question here live? That doesn't seem to be to be the case. So again, thank you very much, Paula, for the excellent contribution and also answering the questions very actively. Then our third presentation was from Silvia at Mogu. Are there any questions? I'm not sure I saw any questions specifically to you. I would have a question because you mentioned at the very beginning of your presentation, you said, well, you said that the products you're making is not technically a textile product, and you likened it more to a non-woven. So in terms of processing of the I don't know even what you call it, the fibers or the raw material that you extract from the mycelium. Is that a process that is, in terms of processing, very similar to a non-woven manufacturing process? So does it also use sort of similar technology, machinery than for making of non-wovens? Or how would you compare it in terms of the production to let's say a traditional non-woven production?
Okay, thanks. No, not really. They are not really comparable, since we are not starting from a material which is spread, but it's a really completely different technique to grow the material. Maybe the difference lays in the word grow, since it really starts from these residues and it grows like this, and then it forms a completely new layer. So it looks like that it grows from nothing. But in terms of process, no, it's not really comparable to non-woven materials. Maybe there are some similarities in the post-treatment, since one of the possible processes is to lay this new layer on top as a coat, as a coating. We don't really like this way of treating the material, since we prefer to make it consistent. What is appreciated is that it is one material and not two materials binded in a way, or one layer on top of another. So it may be similar in that sense, but it's not our preferred way to operate. If we have to find a way to find a collaboration with traditional textiles, it can be coupled with textiles, or we have also tried to grow the fungus through the textile or through a net. So this is another way to do it. Indeed, there's another company that has already patented this process, so it's not our core, but it's another way to grow the mycelium. Or again, what we are doing is to take residual fibers, so for example, jeans or other fibers that are shredded, and they are mixed with our chitinous material in another fermentation way, which is a dynamic fermenter. And this makes one unique layer of chitin that acts as a binder and these recycled fibers. So in this way, textile are more present, let's say. But in terms of process, not very similar to non-woven.
Maybe more comparable to a paper making process, perhaps.
Yeah, indeed. Yes.
Yeah. Okay. Well, then that's clear. And then maybe another question: when you look at, obviously, I guess a big challenge for these kind of really new materials and bio-based materials is always to scale up. So if you look at, if you really want to scale your process, your production, so on, what would you say are the biggest bottlenecks? Is it the growing of the mycelium and the sort of the fermentation process? Is it then the processing into the material? Is this the treatment of the material? What would you say is where were the biggest bottlenecks for rapid scaling? Because that's often an issue for bio-based materials.
Yeah, I would identify two main bottlenecks. The one is more technical, and the other one is economical. The first one is related to keeping the condition as sterile as possible. What we are doing during the process is, I have it in front of me indeed, we have set up a pilot scale production, but it's not industrialized yet. It is labor intensive. So even though we are working with white rooms, white chambers, and we are trying to make it as sterile as possible, it's not easy when you have such high level of man work. So the next step should really be the industrialization and creating a system that's intended for this kind of process. So it's biology, and the risk of contamination is really high. So that's one of our main bottlenecks. And then on the other end, it goes together the high amount of labor-intensive work that we have at this stage. So the next step is really a huge step, that's the industrialization. We are designing a new plant to scaling it up to the next level, so to a demo scale production. And it will really be very different compared to what we are doing now. So yes, working with living material has these risks.
And then obviously the scale of the automation will also then probably have a positive impact on the economics, because that's the thing that you, I think, alluded to as well, is that if you have a lot of labor intensive processes, then
indeed
the cost
it's our
of the material
main
is
cost.
too high.
Yeah, it's our main cost now, the labor part.
Okay, that's very clear. Okay, just looking into the round here. Any other questions for Silvia? That's not the case. Then also, thank you very much to you, Silvia.
Thanks
and
to you.
well, we
Thank
hope
you.
also that the MiFi project will join our Circularity
Indeed,
Multiplier.
yes, yes.
Perfect.
I will write an email to you later, but yes, we will be glad to join.
That's excellent. Then we'll
Thank
be
you.
sharing. I'll say a few words before we close right now, also
Perfect.
on the next step there, so that could be helpful for you too. Okay, so thank you very much. And then we will go quickly to Pirjo, to Finland. Again, quick check if I haven't overlooked anything. Obviously, you are presenting the most early stage project of today, so clearly there wasn't much to be said about the actual project work and the outcome. So I think probably that's also the reason why there's not a lot of questions around it. I think for me it was interesting to see really this really systematic or systemic approach, which I think is often missing still, that we try to solve certain part problems in the whole sort of textile circularity challenge, but it's not the whole systemic approach is not fully thought through and fully mapped out. So I think that's clearly something that for
the
tExtended,
kind of integration of data information and this technology development is key on this. It's very clear from many presentations that we need to know many things on the previous round and on the also for the next kind of use cycle. So what is needed and what can be there and what cannot be there. So knowing the chemicals content and fiber content is of course important, but also how we can use existing chemistry on the finishes, for example. If we know everything what is in there, can we use that in the advantage? It's very interesting. There are a lot of possibilities, and we have a quite large budget for solving these problems.
Yeah, and I think it's not just the let's say the data of the main data items, but also to develop these kind of standards for
classification for the waste, and also for kind of some kind of model for data sharing, for getting requirements, kind of information going on multiple directions. So the requirements come from kind of through the value chain, and also then information of the materials on the other way. So there are a lot of interesting models and standards we can test in also on this data point of view, which is not in my my expertise, but we have a lot of experts on the consortium and at VTT as well, who are solving these kind of data information sharing problems, which is interesting to me as well.
And yes, and I think the data science is something that we need to bring in much more. That it's not just the textile circularity is not just an engineering problem, but I think it's a lot also a data science and a data management problem. That you have to capture the data, you have to analyze the data, and then you have to exchange the data in a system and so that everybody can optimize their solutions and their operations according to an overall outcome and not just to their own outcome of their individual stage of the supply chain, because that's, I think, what often happens these days and what is then getting often called greenwashing, that companies try to impact what they can impact, which on their local level or on their individual step may make sense, but in an overall solution doesn't necessarily lead to an improvement or sometimes even to a worse outcome. And that's, I think, where, again, systemic approaches where they say you have all the data and you can optimize across the entire system and show that that solution is really objectively better, more sustainable according to a very specific defined outcome than an existing other solution.
Yeah. Very exciting to get started.
I believe so, and I wish you all the best kicking off this big project, and I'll be happy to following it all along in the TCMI.
Thank you.
So I see the Teams tells me we have 5 minutes to go, so I still want to give also the opportunity to Helena to see if there are any questions. Again, nothing in the chat. From my side, it's a very different area here. We're looking into, of course, applications of these bio-based materials in technical domains, which have very strict requirements, where I think often the main requirement is a functional requirement to say, can this bio-based solution in terms of function be as good, as reliable, as durable, as functional as an existing fossil-based solution, fossil-based fiber, where it is, I think, more often than in the world of fashion, where it's all about technical function. And that, I think, is probably, and that's, I think, what you stressed as well, that's what you really try to show for your solution, is that there is, at least there's no inferiority. So at least it's as good, maybe if we can even better, but at least to show that in terms of the functional characteristics, it's not worse. Which I think it's often this discussion that you often have also with regard to chemistry, for instance, that you have these kind of regrettable substitutions where, yes, you have something that is maybe more circular, more bio-based or something, but it doesn't last as long. It doesn't have the same functionality. It may create problems in the use, and that's not really what we want to see, especially when we talk about technical products that have to meet safety specifications, flame retardants, all these kind of things that you want to see in technical applications. So I think that's what I took away from it. I don't know if you want to stress that point once more, and maybe.
No, that's what I meant, because we are going to develop the materials, and also, of course, for example, the particles and the caps, the functional capsules and all of that, they are going to be bio-based. They are also aimed to improve the properties of the materials, so that we can achieve the final materials with, of course, at least the same properties than the fossil-based counterparts. And the literature shows that it can be possible. Let's see if you can do that in practice. Let's hope so.
That's of course the big thing, and I think it's similar to what we discussed in the example of MyFi, that even if it's technically possible, there's often a big step to the economic viability of it, which goes through the scaling, through the automation, through the whole value chain management again, so that a fiber that looks similar to an existing fiber may still behave differently when you try to spin it, you try to weave it, you try to dye it, you try to finish it in some way, and then, or to the end user in the end. So, and all of that needs to be taken care of before something can replace a known alternative.
Yeah, that's why we here also focus a lot on the manufacturing processes, because all of them have to be adapted for the new materials. Yeah.
Excellent. Okay, well then thank you also, Helena, for your excellent
Thank you.
contribution. And we will share, of course, your slides if you allow us to. I think Camilla is managing that with you. If there are any slides that you don't want us to share, then we can also remove them. What I would like to do in the remaining 1 or 2 minutes is to quickly show you what we plan as the next steps. So quickly bring my slides back onto screen. So in terms of the Textile Circularity Multiplier initiative, so we are in the process of confirming the involvement of those projects that have not yet fully confirmed to us. And we're also finalizing a document that we call the Terms of Reference that should explain to the participant projects clearly what the objectives of the initiative is, how the initiative will work, and what it means to be a member or partner of this initiative. And then we also, you should know that the European Commission is very, very keen to work with that initiative, because they want to see collaboration between the various projects that they fund. They also want to see the outreach, the dissemination to a wider community. So from that point of view, we have a lot of support from the European Commission to launch this initiative, and they would be joining it in some form. So what we plan is to have our formal launch event, which then involves those projects that have confirmed in late January 2023, where we then also agree on the terms of reference and then start to work on the specific items that the projects wish to work together on. In any case, we will also continue the dissemination activities. So we haven't yet fixed a specific date, but we expect sometime in the first quarter of 2023, we will have another of these webinars, most likely to present to you those projects that neither in September nor today were presented. So that may also include then a few of those projects from the Circular Bio-based joint undertaking, if they also decide to join us. And then also a possibility could be to bring back some of the projects that presented earlier, but with some further progress or more specific presentations on their work and their results. So we will, in any case, keep the wider community also in the picture about the initiative, and make sure that you also benefit from this initiative by getting access to what these projects do, and to be able to ask questions or to interact with the coordinators or partners in these projects in areas of your interest. So this is what we are planning to do. So the Textile ETP will continue to serve as a facilitator of this initiative. So if you have any questions to us, any feedback, any suggestions for this, you know where to find us. We are reachable. Well, you know our website. We have you can reach us by email and also through LinkedIn and Twitter. So feel free to give us feedback. We're always keen to receive feedback from you, so that we know we do the right thing and we do it right. So if there's no further questions or comments at this point, then all it leaves me is to thank again our speakers, thank all our participants for being here with us today, thanking my team behind the scenes, especially Camilla here, for all the work that was done. And then we're coming close to the end of the year, so I may use that occasion already to wish you a Merry Christmas, an excellent and relaxing and re-energizing year-end break. And then we look forward to see you all again here in the new year with more textile circularity and sustainability innovation. So thank you very much all. Have a nice evening.